Section 8.3 is using intercepts. I can use x-intercepts and y-intercepts to graph linear equations. We can graph a linear equation quickly by realizing that only 2 points are needed to draw a line. It's usually easiest to choose points where the line crosses the axes. The x-coordinate of a point where the graph crosses the x-axis is called our x-intercept, and the y-coordinate of a point where the graph crosses the y-axis is the y-intercept. To find the x-intercept of a line, we substitute 0 in for y in the line's equation and solve for x. And that's because an x-intercept, wherever it happens, our y value is always 0. So whenever it crosses the x-axis here, our y value is always 0. So we can plug in 0 for y and find our x, and that tells us where our graph crosses. To find the y-intercept of a line, we substitute 0 in for y, or 0 in for x, in the line's equation and solve for y. And that's because our y-intercept, no matter where it happens, has an x value of 0. Whenever we cross our y-axis here, our x value is 0. So we can substitute that 0 in for x and solve for y to get that value. And then once we have any 2 points, we can draw a line through them. So we're going to find the intercepts of the graph here. Again, to find my x-intercept, I plug a 0 in for y. And to find my y-intercept, I plug a 0 in for x. We get rid of the opposite variable. So to find my x-intercept, I plug a 0 in for y. And negative 2 times 0 is 0, 3x plus 0 is 3x. So we don't need this anymore. To find our x-intercept, we get rid of y by substituting in a 0. And then we solve for our x. So here my x-intercept is 2. And I say x-intercept rather than just x equals because we know x equals is a line. We don't want a line here, we want the point. I can also put that point in as x is 2. We said y is 0. To find my y-intercept, I make x 0. Because we want our x to disappear. 3 times 0 is 0. 0 minus 2y is negative 2y. Divide by negative 2. And my y-intercept is negative 3. Again, we said that x is 0 and y is negative 3. Okay, so to find our variable, we just get rid of the other one by making it 0. Now here we're going to graph example 1. We said our x-intercept was at 2, or the point 2, 0, and our y-intercept was at negative 3, or the point 0, negative 3. So our x-intercept is 2. That's where it crosses our x-axis, or we can graph the point 2, 0. My y-intercept is negative 3. That's where it crosses my y-axis, or I can go with the point 0, negative 3. Either way, it gets us to the same spot. We can connect a line through any 2 points. Usually we want more than that if we're not confident in our points, just to make sure that we have the right ones. But here with our intercepts, we can go ahead and connect the dots. Make sure our line goes through both of our points. We want to extend it, and then arrows to show that that pattern continues. Feel free to pause here and give these a try if you'd like. We're going to find the intercepts and then graph. Intercepts and then graph. So to find my x-intercept, I plug a 0 in for y. That makes this whole part go away. So I have x-intercept equals negative 2, or the point negative 2, 0. X is negative 2, y is 0. To find my y-intercept, I plug a 0 in for x. I bring the sign down with my number, divide, and my y-intercept is 1. The point there, x is 0 when y is 1. So here are my intercepts. Now we're going to graph. We said x is negative 2 for an intercept, or negative 2, 0. Y is 1, or 0, 1. We can connect those with our straight edge. And arrows to show continuous. Remember, we want to extend that through those lines, so we have a nice big line here with those. For number 2, to find my x-intercept, I make my y value 0. And I have 4x equals 12. So divide by 4. And my x-intercept is 3, or the point x is 3 when y is 0. Now, to find my y-intercept, I make x 0. That part is gone, and all I have left is 3y equals 12. Divide my y-intercept is 4, or the point x is 0, y is 4. To graph these, my x-intercept is at 3, that's where it crosses my axis, and my y-intercept is 4, positive 4. Now we can connect those dots. And arrows to show it continues. Number 3 here. To find my x-intercept, I plug a 0 in for y and solve. So I have 0 equals negative 2x minus 8. Add 8 to move it to the other side. Now divide. And my x-intercept is negative 4, or the point negative 4 for x, y 0. To find my y-intercept, I plug a 0 in for x, which makes this entire part go away. So my y-intercept is, don't forget your sign in front, negative 8. We said x is 0 when y is negative 8. So here, my x-intercept is negative 4. My y-intercept is negative 8. And we can connect those with our straight edge. And arrows to show that that pattern continues. In example 3, you are canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip. Give 3 possible combinations of paddling and drifting times. So here, remember that distance equals rate times time. And we're traveling a total distance of 12. And that's our distance paddling and our distance drifting. We add those together to get our total 12. So we're going to take our rate times our time. Our rate paddling is 4 miles per hour. So I'm going to do 4 times, I'm going to make x my time paddling. And 2 miles per hour when drifting. So 2 is my rate, y is going to be my time drifting. And we could have used p and d here, but since I am going to graph this, I wanted to use x and y so we knew which axis. We could have just labeled our axes different, but we can use x and y as well. Just make sure you tell me which one's which. Now, as far as graphing this goes, remember we have paddling here, and drifting. Is our y. X on the bottom, y on the side. We're going to use our intercepts here. So to find my x-intercept, I'm going to plug a 0 in for y. And I'm going to have 12 equals 4 times x. To get rid of our multiplication, we divide. And 3 is my X-intercept. To find my Y-intercept, I'm going to plug a 0 in for X. So 12 equals 2 times Y, divide, and 6 equals my Y-intercept. So what that means, guys, is for my X-intercept, or my paddling time, if I plug a 0 in for Y, that means that I'm not ever drifting, I'm just paddling. So if I paddle the entire time, it's going to take me 3 hours. Plugging a 0 in for X to find my Y means I'm never paddling, I'm just drifting the whole time. Okay, so I'm just drifting, never paddling. Here, we can connect those. Maybe. Try that again. And the question asks for 3 possible combinations of paddling and drifting times. So some possible combos for paddling and drifting. We can paddle 0 and drift 6. We can paddle 1 and drift 4 hours. We can paddle 2 hours and drift 2 hours. We can paddle 3 hours and drift 0. We also could have done something like, we could have probably paddled for an hour and a half and drifted for 3 in the middle there. We could have spread our graph out here, gone by like every 2 squares being 1, gone by halves, and that would have given us some more options too. But here are 4 possible combinations just the way it is. So we could have drifted for 0, paddled for 0, drifted for 6 hours. We could have paddled for 2 and drifted for 2. We could have paddled for an hour and drifted for 4 hours. Any of those combinations would have worked there. And that's all I have for section 8.3.